I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Operational Technology Risk Assessment. My name is Steve Warzala. I am the CSIAC Outreach Manager. A few administrative notes before we begin. All phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. In time permitting, your questions will be answered at the end of the session. Today's briefing slides will be posted on our website within a few days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. Funding that DTIC provides enables CSIAC to conduct these webinars. CSIAC is currently participating in the National Cybersecurity Awareness Month campaign. Each week in October has emphasized a different theme. This week, the focus is on safeguarding the nation's critical infrastructure. Given that particular emphasis, it's my pleasure to introduce our presenters for today's webinar. Dr. Rampal Hollington is a cybersecurity consultant, a risk management framework RMF subject matter expert, and an adjunct professor of cybersecurity at Utica College. He served in the U.S. Army for 21 years in various positions, including Information Assurance Manager and IA Security Officer, Information Systems Security Officer, and ComSec Custodian. Over the past 11 years, Rampal worked in support of cyber programs for the Missile Defense Agency and both the U.S. Army and Air Force. Dr. Hollington also served as a special agent with the Defense Security Agency, responsible for the certification and accreditation oversight of cleared contractor IT systems. In addition, we have Stephen Brewster, who has expertise in software assurance, systems integration and testing, as well as cybersecurity governance and risk management. He was instrumental in leading unmanned systems contractor organizations through the integration of software assurance tools, standards, and processes. Mr. Brewster also served as cybersecurity manager of the Federal Division of a leading provider of facility-related control systems, FRCS, and has presented on the topic of RMF for FRCS around the world. I will now turn the presentation over to Dr. Hollington. Good afternoon, Rampal. The floor is yours.
Good afternoon, and thank you for that wonderful introduction, Steve. And I want to welcome everybody to the briefing, to this presentation, and thank you for attending this important topic. To start, just want to let everybody know the purpose of the presentation is to provide an understanding of the risk management framework process from a system level perspective. The intent of this is not to make everybody an expert, but the briefing is intended to bring awareness to the RMF process and highlight some specific nuances of the process with respect to the control system environment. In this presentation, we want to discuss what RMF is and the 6 steps required to develop the security program. We're also going to look at the security authorization package and how it fits within the RMF process. To bring awareness and context to why there's a need to conduct RMF activities in the OT environment, we're going to briefly look at the history of authorization and a quick look at the top 10 cyber attacks against industrial control systems, as well as the roles and responsibilities associated with the OT RMF team. Based on our experience with conducting the assess and authorize process for OT and under the RMF process, we'd like to reserve a good amount of time to discuss what we call the problem space in OT. We'll look at some of the questions that were raised and issues faced by some of the OT people, the personnel in the OT environment, as well as related to the RMF process. The intent is to offer the audience things to consider during each step of the process to successfully develop a program and obtain an authority to operate. And lastly, we'll leave some time for some questions and answers. RMF is not compliance. RMF is used to aid the system owner with managing risk related to their unique environment.
Exactly. It's a framework, right? For the DoD environment, it was put in place today under 85-1001. I think the latest revision is July 28, 2007. Simply put, the objective is to establish cybersecurity policies, assign specific responsibilities, and it does this over the management of the life cycle for the system. It also allows the individual to manage the cybersecurity risk for said DoD IT. The mandate, it mandates that RMF should be and will be consistent with the National Institute of Standards and Technology, Special Publication 837. So what are those consistent and principles that DoD 8510 is referring to in this? To sum it up, really is to ensure the information system and related security risk supports the organization's mission and their business objectives. That's key. It also is to ensure that security requirements for the information system and controls, they integrate as seamlessly as possible into the system's development lifecycle. And it also provides this interesting term, ongoing security authorization. And it does this through a layer of transparency into the information systems environment and how that system is communicating security risks. So what we're going to do real quick is we're going to talk about how this is accomplished. And I'm sure many of the individuals on the phone today and that have dialed in or whatnot or on the webinar have seen the 6 steps, right? We've gone through or participated in and kind of what that looks like. So we're not going to spend a lot of time there, but we are going to briefly go on and explain it so that we're all talking the same language. So step 1, what is the objective? What is it called? This is categorization, categorizing the system. The governing documents for categorization is FIPS 199 as well as 860. 199 is a key document, right? Federal Information Processing Standard that provides security categorization guidance for non-national security systems. And 860 is like your lookup guide or table that maps information types to your information system. During this particular step, the goal here is to identify the impact levels of confidentiality, integrity, and availability. And you will hear later in this presentation, we'll refer to that as the security objectives for your system, and to document that. One key thing to note that during this step, you also want to capture what your authorization boundary is and what that set of information resources that are defined in that boundary. Those resources are really simple. They're your people, the technology that you're using, and even the funding that you need in order to implement it. Step 2, which is your selection of your security controls. This has to be geared towards your unique environment. I think you guys saw that on the previous slide. Every system has some unique aspect of it that it has to implement in order to meet its mission or the business objectives. And step 2 is when you select said security controls in order to define what that environment looks like and how to secure it. It's governed by 2 documents here, FIPS 200, which is nothing but a minimum set of requirements that you have to implement for federal systems, and 853. And it's funny, if you open up this FIPS 200, it pretty much points you to 853 and tells you to follow that security and privacy controls guidance for selecting and tailoring. There are a lot of controls in place during this step that have to be considered based off of your categorization. I think there's over 800 total, 17 control families for security and 8 for privacy. Once you've established your security baseline and you've tailored it specific to your unique environment, you move on to step 3. Now, inside of step 3, this is where the rubber meets the road, if you will. This is your implementation. One key aspect here is to ensure that during this phase, you exercise your control. You define what they look like in the previous step, and you set up various responsibilities for who's doing what and what it's going to take. But during this step, it's the opportunity for you to actually exercise it. And obviously document your results. It's of those results that under step 4, assessment, you will be evaluated again. And the shortcomings of your implementation of your agreed upon security controls in step 2 is ultimately what's going to be detailed out in the assessment report under step 4, the assessment of said controls. So any and all shortcomings within your implementation undergo a risk analysis by the assessor or under this particular step, and that risk is then provided into step 5 for the determination of authorization for your system. So under step 5, this is where most individuals in the OT environment who are really focused on the availability of the system, they're just wanting to get said ATO. And as we state here on the slide, RMF is not an ATO. It's a framework. It's a process. But under this particular step is where said risk that was quantified and calculated during step 4 is determined to be acceptable and accepted for a specific amount of time, or you could say for how long. Step 6, the last step, is monitoring. This is where the ongoing authorization through transparency into your environment takes place, right? So it's more the same. You're going to, over various frequencies, you're going to be reevaluating your security controls, reevaluating your security impacts of your confidentiality and integrity and availability, and you're going to be managing the security over the life cycle of the system. Lastly, RMF is fun, at least I think so. Next slide. So we said it's not an ATO. We kind of went through the steps fairly quickly. There's a lot of material out that explains what this looks like, so on and so forth. But let's talk a little bit more about what actually comes out of each step. A lot of times people get lost in the woods when they execute or go in to implement RMF. They don't know what personnel they need, things of that nature. And more importantly, they don't know what tangible document or artifact is supposed to yield from each step. So looking at step 1, what you're looking for here is a categorization justification that communicates your impact levels. If you lose confidentiality to your system, an unapproved user or unapproved person has access to your data or your information, to what impact does that have on your business? How does that impact your mission? It is the documentation of that information under a categorization justification that you're seeking approval for from your governing faction or your authorization official. Step 2. So with your system now having a documented understanding that confidentiality is a serious thing and it's an extreme impact to our environment, to our people, to our nation, to our system, if it's compromised, that gives you the ability to then begin developing your system security plan. It allows you to follow your NIST 853, as we talked about previous slide, to select and tailor various controls that have already been outlined per how your system was categorized. The one key thing about your system security plan to take away is that it becomes the basis upon which residual risk is assessed and evaluated for your system. It provides the system owner the ability to document, hey, my system may not perform auditing the same as, say, the IT system on this particular campus, or that provides us a backbone performance auditing. In my OT environment, a lot of my auditing might be performed in my data historian, or there may be a manual process that has to take place in order for us to pull audit files. My system may not seamlessly integrate into your standard IT package. And thus, during this particular step, you can write explicit instructions or descriptions on how you plan to implement these particular controls that are allocated to your system. Now, under step 3, we're going to perform a self-assessment. Step 2 yielded a system security plan that we must execute to, that we developed, that we tailored. And step 3 is going to be an opportunity for us to not only just implement our system security plan, but also document the results. And the results of your implementation will be whether or not you're compliant, non-compliant, or whether or not there requires additional funding or resources in order to implement, say, one of the controls that were in your baseline. And this evidence, this self-assessment and this evidence is going to be key because it sets the basis up for step 4, which is your assessment. The output of step 4 is a security assessment report. And we'll talk about the roles of the individuals performing these steps in subsequent slides. But that security assessment report is going to be the key document that provides details as to which, or as to how well you implemented your system security plan. As we stated earlier before, that plan is the basis upon which residual risk is calculated. And under step 4, that security assessment report, that's the evidence of the residual risk from your plan. Did you implement those things that were outlined in your system security plan? Step 5 is your plan of action actions and milestones. This is going to provide the system owner an opportunity to communicate if there were shortcomings in my implementation, what resources that are needed, and what is the activities that need to be performed, and what timeline is necessary in order to get those things completed. And then step 5 is the coup de grace, is the authorization decision. This is the acceptance of risk that was documented under step 4, which is simply the shortcomings of implementing your system security plan. It's acceptance of risk by the AO for you to continue operating for a certain amount of time. One key takeaway from this slide is to note that the security authorization package is a manifestation of your security program, and that the purpose of the security authorization package is to document and manage your risk. Next slide. Okay, so one issue that constantly arose is why? Why now? Why do we have to conduct RMF activities for OT? We understand the language as is written in the past, specifically geared towards information technology, workstation servers, switches, routers, but why now control systems? So one thing that my colleague and I constantly talk about is the ever-changing threat landscape. And one aspect that we identified was through some research published by Kaspersky 2018 that said that more than 40% of ICS computers were attacked in first quarter 2018. And the codification and heuristics of those attacks, they kind of laid out in maybe a top 10. And here they are. Number 1, insider threat. You can see IT insider, common ransomware, 0 days are definitely an issue. Individuals can purchase ICS equipment, sit in their lab, pick it apart, understand its inner workings, and create 0-day attacks all the time. And ransomware, we've seen that attack constantly within the medical industry. The Ukraine attack and things of that nature are constantly manipulating and changing the threat landscape and bringing a lot of risk to ICS. We found there was a publication of analysis of a specific type of malware called Triton, which was geared towards a piece of software, Triton software. Triton software basically specializes in safety information instrumentation systems, and it pretty much, if something's going wrong in your processing environment, that SIS, that SIS, that safety instrumented system, is what shuts it down or what controls it from getting out of hand and causing physical damage. Well, this particular software malware was geared directly towards that SIS controller. So you can see the concern. Some aspects of it that was published by FireEye in 2017 was that it followed kind of a Stuxnet model that came out against Iran in 2010. The controller that was deemed compromised wasn't well secured, and access to said controller was through a workstation that had no whitelisting. There was no type of access control to it. And also there was no real segmentation between that environment, or the workstation and the SIS, and the business network. And so we look at this and we say, okay, we know these threats are real. We understand that the landscape is changing and that the attacks are coming towards ICS. How does RMF play in protecting us from it? Why does RMF activities help? But if you look at how that system was compromised and how Triton works, there's simple things that could have done in order to compromise, to support mitigating that particular attack. Things like your data flow diagram and monitoring said traffic, or leveraging hardware features and talking to your control engineers to understand what you can do to secure that environment. Next slide. So a brief look at the why now. If you look at it over time, since 1990, the definitions of what IT or what information systems should follow the certification accreditation process has grown. Under DITSCAP, you saw that it was directly applicable to all DoD systems that collect and store and transmit, right? 2001, they began expanding that definition, and now today there's an explicit focus and call out of industrial control systems and platform IT. I mean, they get down to the brass tacks and actually call out maintenance equipment, calibration equipment, and weapon systems. Next slide. And so why me? You know, a lot of OT operators that we've had the opportunity to work with in the past really asked why and what involvement do they have. They still believe that it was a network responsibility. But there are key roles and members within this particular environment that all have key responsibilities. Kaspersky published a quick insight or artifact saying that 58% of companies understand that trying to find an ICS cybersecurity employee is extremely difficult, trying to find those right skills. And I participated in some efforts under 8140, the cybersecurity workforce management, to try and define what those knowledge, skills, and abilities should be. But in looking at this particular slide, you can see there's your standard cybersecurity personnel, and then there's your OT operators. And those two particular domains have to work seamlessly together in order to work through a system security plan, write instructions or plan security control implementations that gears towards their environment, that's geared towards their system. One primary example that's seen is if you take a look at this standard for implementing, say, a network device, there's a security technical implementation guide that's out there that tells you what you have to do in order to configure a network device. However, a building point of connection or a network controller can be deemed a network device, but that particular stick could and would yield that controller inoperable. And so it's important that your IT or your cybersecurity team work with your OT team in order to develop unique, specific configuration guidance that meets the intent and the implementation plan defined in your system security plan. So some of those roles I'm sure you're familiar with, maybe the AO, they render authorization decisions. The ISO is really responsible for over 80% of the responsibilities for executing this, the ISSM, so on and so forth. The unique roles in the OT environment that have to come together are roles like your process engineer, your operator, and your programmer. Next. So this leads us to security is like an umbrella, right? You don't really know you need it until the rain starts to fall. So I'll turn it over to Dr. Holland.
Thank you, Stephen. Well, developing an RMF program serves as that umbrella by putting in place controls, plans, and strategies for when a threat materializes. And I want you to keep in mind that the threats are both external and internal in nature, and it's also caused by unintentional events or activities. With that said, there are some questions that we've heard from the ICS community as they tried to navigate through this RMF process. And one of the questions was, what kind of system is this? Some of the members in the ICS community had a hard time determining what type of system it is. And as Stephen mentioned earlier, the definition of systems within DoD has changed over the years. And there's been great discussion concerning how to categorize these systems. 8500.01 and 8510.01 incorporated platform IT or PIT into the RMF process. And these instructions recognize that PIT differs from traditional IT and that it is dedicated to the specific operation of a platform. And PIT can be a product, it can be a system, or it can be a subsystem within that environment. DoD also recognizes that the most common form of PIT are control systems, and this includes industrial control systems and SCADA systems, as well as other types of control systems. But with respect to the RMF process, these control systems have dependencies, and these dependencies are predicated on other systems or organizations, helping them meet specific needs. So another question was, what are these dependencies? Well, the answer to that question is not a one-size-fits-all. It depends on your operating environment. The development of a system security plan should help identify what those dependencies are. And during the selection of the RMF controls, your RMF team, and we talked about the security personnel as well as your OT engineers, they have to work together to determine if there are outside agencies involved with operating your system. And I'll give you a quick example. If the configuration of your patches and your workstations are managed by the base comm squad or some local NEC, then these controls will be inherited, and your security plan has to identify that these controls are inherited or the CCIs are inherited. And if you rely on physical security or your switches and routers are managed by some other agency, again, these controls are inherited. and that common control provider must provide inheritance for these controls in EMAS, which is the system of record, or if they're not in EMAS, then there must be some type of signed agreement that supports that these dependencies are being inherited from another organization. The key takeaway for dependencies is that if the control is inherited, then the system inherits the status of that control. So if the common control provider has a control that's compliant, then your system is operating within the bounds of its system security plan. If it's found to be non-compliant, then your system inherits that non-compliant from the common control provider. And this is critical with the categorization of the system, because as you look at the information types that you have, the information types that's stored, processed by your system, you have to categorize your system to make sure that you are getting the right security objectives and the controls put in place. And some of the energy managers and some of the OT personnel have asked, what type of information do I have on my system? Well, Stephen alluded to it a little bit earlier. NIST 860 develops a process map to help categorize the information in the information system. And there are three key areas that make up the information types for categorization. And you have to look at the mission and information types and the delivery mechanisms for that, the service delivery and support function and the information types associated, and the government resource management functions and those information types. And they're laid out pretty well in NIST 860. And it's critically important to select the information types that are processed by your system. If you arbitrarily assign a categorization to some of the systems or to your system, then what you're going to have is two costly impacts to your security program. First, your categorization is going to be too low, and there'll be a gap in the security mechanisms applied to your environment. Or the categorization will be too high, and then the cost to operation will increase because of the additional controls that may not be necessary for your environment. Part of step one of the RMF process requires a comprehensive inventory of hardware and software and firmware. And many of the ICSs have been operating for years, and a comprehensive list of inventory is not available, which was another concern. And the OT environment asks, why should I have to bound my inventory and my system? Well, without a comprehensive understanding of what's part of your system, the RMF process can't be developed to address the risk associated with the hardware, the software, or the firmware that you have in your authorization boundary. And if the inventory is incomplete, it is difficult to determine if the control selected in step two are too restrictive for your environment, or if it's too loose for your environment and you're not getting the coverage that you need. So Stephen talked about the RMF personnel, and one of the key people within this process is your information owner, and that information owner has huge responsibility across RMF. I believe there's 22 steps within this process. The information owner has 16. So your system owner has to be identified up front, be engaged, and have the proper training in order for you to develop the program under the step. Next slide. I'm going to give you a second to read this. It kind of alludes to some of the issues that we're having with arbitrarily assigning things or just trying to get an ATO. Next slide. Well, after the system is categorized in step one, the next step in the process is select the security controls. So what controls are applicable? Steve told you 853 provides that baseline set of controls, and it's based on the impact levels to the system. All the controls associated with impact level, they're initially selected as the provisional baseline set of controls. Additionally, 882 offers an ICS overlay, which suggests tailoring of those baseline controls. We've seen it where a number of these ICS systems have taken 882 and blanketly applied it across their system. I will caution you about doing that because when applying that overlay, each control must be visited to determine if it's appropriate to remove that control from the baseline, because some of the controls have an impact on upstream processes or systems such as your HMI. And we understand that down at the actuator and sensor level, certain things can't be done, and it can be removed from that portion of your architecture, but at the levels where it's appropriate, it still should need to be applied. So the ISO needs to understand the operational capabilities of the system and the components before removing any of the controls from the baseline as suggested by 882. So who's responsible for implementing these shared controls? That's another key element of a security plan. And depending on your inheritance model, those CCIs may be shared between you and your common control provider, and then your security plan has to spell out what responsibility each party has. The ISO has to evaluate all partnerships, all inheritance, and make sure that there's a service level agreement, an MOU or an MOA, or some type of maintenance agreement that's in place in order to achieve the security objective. So why should the OT system security plan differ from an IT security plan? Well, if you're working with a common control provider or on the system security plan, your plan has to be treated differently because you are unique. Keep in mind the system security plan is specific to your operating environment, and it identifies deviations from the implementation required as specified by the control. There are things that you can't do at certain levels of your architecture that you have to be able to articulate that to any common control provider or within your system security plan. So your system security plan should be different than the IT security plan because it may be technically infeasible to implement antivirus on an actuator or a sensor or implement data at rest encryption on a PLC. So you have to spell these things out. You got to document the deviations from the requirement, but then provide details for how or what you're going to do to meet the intent of that control. Next slide. So during this step, the ISO developed the SOPs, and they developed all the SLAs and MOUs, and now they have to exercise that inheritance model. And the purpose is to validate the services are being rendered and that the controls are achieving their intended outcome. The ISO also has to perform a self-assessment and document how each of the controls functions in that environment. So copying an SOP where someone else was successful at getting an ATO, it's not appropriate, and it may have unintended consequences or create an environment where your system cannot function. And I'll give you a quick example. There was a system that copied an SOP that talked about updating their antivirus weekly and a host of other things. Well, when their common control provider executed their system security plan and they updated their antiviruses weekly, what they found was that there was a conflict between certain software components within their head-end environment, and it shut down the head-end environment for weeks, and it had an impact on their ability to provide meet their business functions. So in reality, you have to specify how your operating environment is going to function. In an SOP that was successful, it's not going to work for your environment. The reality in this situation is that the ICS system was also dispersed across 500 square miles, and updates had to be performed manually. And on many of the systems, you couldn't even perform antivirus updates on the systems. Next slide. If you're assessed outside of your security plan, it's your fault. So why do we say this? Well, as part of step 4 of the security assessment, you have to perform a security assessment. And that security assessment should focus on the approved security plan and the self-assessment that you conducted in step 3. A properly documented security plan explains how a given control will be implemented and specific to the ICS environment. And remember that the SSP is approved by the AO in step 1. Security controls selected are selected and implemented based on that approved security plan. In step 3 of the process, a self-assessment is performed to determine how well the security objectives have been achieved and any weaknesses found documented in the POAM. Well, when the SCA validates if the controls were implemented according to the stated security objectives in the security plan, and then if the system owner assessed that system security plan appropriately. So why should the system owner obtain a security assessment plan? First, it's required by NIST 853. But more importantly, the purpose of the security assessment plan and that approval is to establish the appropriate execution of the security control assessment. And that's key because it bounds the level of effort for the security control assessment and ensures that the appropriate level of resources are applied to determining security control effectiveness. So why is this important? If your environment doesn't contain a Linux operating system, would it be prudent to have a Linux administrator as part of your assessment team? If your SSP identified that a vendor-recommended security configuration guide be used to configure the BOC or some other component, you want to ensure that that methodology uses that guide stipulated and approved for use in your security plan. Another quick example is that we were supporting a security control assessment, and Stephen alluded to this a little bit earlier. The security control assessor assessed the BOC with a layer 2 switch.
The BPOC was the building point of connection. That's your control.
Yeah, assessed the BPOC with a layer 2 STIG, which the BPOC didn't have any layer 2 switches within the BPOC. Had the assessment plans been submitted and approved, the system owner could have ensured that the proper assessment tool was used. As a result of that, the ISO was left with hundreds of false findings that had to be added to the system security plan, which had to be addressed. And that increased the authorization time, it increased the time it took to answer the POAM, and it had to spend additional resources in order to address these issues that should have never been relevant in the security plan. Next slide. After the security assessment, the plan of action and milestone is developed, and this is based on the findings and recommendations from the security assessment report that's provided in step number 4. This package gets assembled and submitted to the authorization official for a decision. So the system received, let's say, a 3-year ATO, but 6 months later it gets disconnected, and this scenario plays out often. Well, fundamentally, there's a breakdown in one of the RMS steps that cause the system to get disconnected. Again, and we'll revisit this over and over again, your approved security plan must explain how the control will be implemented within your operating environment. If your HMI vendor provides quarterly updates after testing patches, then you have to state that in your system security plan. That is how you should be evaluated. If your system can only be scanned for vulnerabilities during a specific maintenance period because you have a high level of availability, then you have to state that in your system security plan. If you're inheriting controls, monitor those controls closely. If the common control provider fails to meet the agreed upon task of meeting the intent of those controls, then you have to take action. Do not wait. Remember, this plan is set up to manage risk. So how we manage risk is going to be important to us being able to operate and not get disconnected. So you have to document that the control from your common control provider is now non-compliant. Place it on the POAM. set up milestones and resources to be able to get the control remediated and articulate that to the authorizing official. The takeaway here is that the system is operating outside the approved security plan. The system should be disconnected because the risk is not being managed appropriately. Next slide. And again, the importance of the security plan can't be overstated. The security plan is written specific to your operating environment. It is the roadmap for managing risk and enabling both operational objectives and compliance with the security plan.
So when looking at a security plan, you can think of it as the manifestation of a program, or I should say a security program is manifested through your plan. A cybersecurity program, or what we've been communicating this entire time, is the ongoing implementation, management of risk through your system security plan. It should do a couple of things, right? One, it should enable an organization's mission and business objectives, and it should also provide workforce development and training. You should be able to identify key indicators that lead to various individuals on your workforce that require key skills, various certifications, things of that nature. As Rep. Paul alluded to, it establishes partnerships and service level agreements. Those need to be executed, re-exercised, re-looked at. And it also helps shore up your supply chain. And I know that's been a heavy topic of late, but in a very simple term, when looking at the security requirements that you've identified in your plan and identifying how you're going to acquire or procure this air handler unit or this particular controller, you understand what confidentiality requirements you need to place on selecting the proper vendor. And in doing so, that is the first entry into looking at how the components or supplies you need in order to meet your mission will be procured. Also, in going and looking at your maintenance and how you're going to be doing updates and IAVAs, and how well that vendor communicates or have their product evaluated for vulnerabilities, aligns with your system security plan and helps shore up your supply chain. The last one is it identifies a response to cyber threats. You know, there are various publications and avenues of information where components within your OT environment are being evaluated, are being tested, and that information is being published so you can respond in time. But a shored up security plan, a well-executed security plan, does provide you the OT security program you need in order to operate. Right, Paul?
Yeah, I agree. I think that one of the key things here is the supply chain cybersecurity. Some of these systems have your vendors connect remotely or bring their maintenance laptops. How well are those laptops secured? Take a look at the vendors' updates and their patches and their configuration of their devices before you allow that to be introduced into your environment. And this is also part of your supply chain risk management. Okay, and before we wrap up and get to the question section, there's a couple of things that I want to stress the importance of in order for to enable success in your operating environments. First, you want to identify your RMS team, and you want to empower them and give them the responsibility as well as the authority to establish and enforce security within the OT environment. I know it is a cultural shift and a cultural change, but if you ever read the book Who Moved My Cheese, we have to find those hurries and scurries that are going to help move this in the direction that we need to. You want to make sure that your personnel are trained and certified to the cyber workforce requirements. You want to document what you are. What information types are you processing? What is the true categorization of your system? Document what you have by inventorying your system's hardware, software, and firmware. Document what you have by developing an appropriate diagrams for the system authorization boundary, the architecture, the information path flows, your ports, protocols, and services that you use within your authorization boundary. Document what you do in your system security plan and do what you say that you're going to do. This will help enable success. identify the inheritance and establish the necessary agreements to demonstrate the controls are being achieved. To reduce the chance that the OT security program is being assessed, not being assessed as a standard IT system, review and approve those security control assessment plans and ensure that the assessment plan aligns with your SSP. And if it doesn't, then you need to turn it back to them and have a conversation and point out where things need to be assessed according to your plans. Keep in mind that the threat landscape continues to change. The risk to your system is constantly evolving. So the OT security program must continuously monitor the environment, assess and document new and changing risks within the security plan, and then submit that update to your AO so that the risk can be reviewed and accepted by your authorizing official. Each OT system environment is unique, and I want you to keep that in mind. The personnel that support the systems are different. The training requirements are different. The inheritance model is different. And the system itself, its function may be different. Your ICS vendors are different. And more importantly, the agency or the AO's risk appetite is different. So you have to make sure that your system security plan shows the uniqueness and how you plan on operating, and it stands apart, and that your system security plan is unique from other systems. And with that, we're at the end. And if there are any questions,
we'll open the floor.
Well, I want to thank you, Rand Paul and Stephen, for that presentation. That was a very nice, thorough overview of the stepping through that six working through that 6-step process. The different phases and what you need to do along the way to to create that plan. So I appreciate that. That was very like I said, a very nice overview. So. So I'm going to pop back just to your last slide for a second, and kind of tying in there. So we've kind of had some instances in the past where dealt with some individual trying to help them do the process, and they've kind of indicated that their system is very large, an extensive system, and they didn't actually have a complete inventory of their network and system in place, and so we've kind of got the question of why can't we just put the whole why can't we put the hardware software list on the POAM and kind of work from there? What do you have to say about that? How would you respond to that type of question?
Yeah, we see that quite a bit. It's again, we go back to the risk appetite of the AO and the agency. If the authorizing official or the agency determine that is a risk that they're willing to accept, then they can move forward in that fashion. But it's not one of those things that I would recommend that stays on the POAM for long periods of time, because you may have outdated firmware that's out on your network, and if these systems are geographically dispersed, they may be exposed to risks that you're not aware of. So you really got to get a handle on what's out there, and not allow this to continue to go on for an indefinite period.
Yeah, I would say you can't secure what you don't know. If you don't know what you have, it becomes very difficult to accept the integrity of your system security plan. There are various controls that are applicable because they're technically feasible and they're in your baseline. And depending on the software and how the software is integrated, and interfaces with other components, or depending on the hardware that you have and how it interfaces with other components, that feasibility might be applicable. And you're looking at an incorrect documentation of what you plan to implement. You're looking at a invalid assessment. Oftentimes, when this type of oversight takes place, where inventory is missing, when the assessor comes on site, they're obligated to document that. And the associated risk with this brand new found, layer 2 switch that you only use for your building, but you forgot to document it or whatnot, becomes a problem. So it can become costly and time consuming, not that it can't be overcome. The goal here is to become up and operating in a timely manner and ensure that that inventory is documented, and that you'll have to go through this one time. You can begin monitoring and maintaining your system. So, yeah, you can't secure what you don't have, and it's vital to ensure that you know what you have before you begin selecting your controls.
Okay, yeah, I think that's the key there, is that if you don't know what you have, you can't secure your system adequately. So that's really the first step in the process, is to nail down your various components, your network, your system, your infrastructure, and then you can start identifying the controls you need to implement to your level of risk tolerance. So appreciate that, your insights and feedback on that question. So one of our other attendees is asking about the shortage of cybersecurity professionals, and asking what are you doing with your students to prepare them for a career in cybersecurity, and what kind of skills are they graduating from college with these days?
Thank you for the question. There's cybersecurity is, and I don't want to get long-winded on this, but cybersecurity is defined differently across a lot of different schools, and primarily Utica focuses on forensics. So, with respect to OT environment, if there happens to be a risk or a vulnerability or an intrusion, then the students that are graduating from Utica College has the capability of going in and doing a forensic examination on your environment to be able to understand the extent of damage and how that vulnerability or that attack occurred. It's been my experience that a focus on the OT environment really hadn't ramped up yet. And it's one of the things that I speak about quite often, because it's such a huge gap within that environment that we really have to start getting individuals trained and skilled in securing the OT environment.
Okay, thanks for that answer. I think it's kind of like you were talking about securing a system. It's not there's not a one size fits all kind of approach. Each college, university may have kind of an area that they specialize in, and as you're kind of noting, the OT area sounds like one that's going to need some more effort, more emphasis put on it in the future here. So appreciate the insights on that. So we've got a question. This might be a little difficult to answer given the differences in systems, but what do you have an idea of the approximate cost and what the cost to complete the RMF process to get to an ATO on a system? And like I said, I know systems can vary greatly in size and complexity. So, but I don't know if you have a ballpark answer to that.
I have somewhat of an answer, but again, this is it's subjective. That cost is going to depend on who you have doing it. And as you know, the level of experience of an individual that functions on a program, that cost increases. If I take an entry-level person and put them on there, then your cost is going to be a lot less. So with that, if you're trying to develop a program, then you must have an individual that understands, and this is specific to OT, that must understands IT and OT and how to integrate those two processes into the risk management framework. If you don't have the right people, then you will not have a developer program. You'll be going after compliance. And again, compliance doesn't give you the opportunity to develop a program to support ongoing authorization. So if the labor category of the individual that's going to support this process end to end, it's going to depend on the level of experience that you have on that task. And again, if the goal is just to get an ATO, then what will wind up happening is you're copy and pasting and throwing everything on the POAM and not getting into developing the program. Stephen's biting at the bit here.
So one of the other interesting aspects is across DoD, all agencies are tackling development of a security program or plan for OT systems. Navy, Air Force, Army, right? And depending on what command and the maturity of that command and their governance and their guidance and how they have communicated downstream what their risk tolerance is and what gates, avenues these system owners need to go through in order to maneuver within RMF will impact cost. There are certain organizations that have segmentation from the DODN, if you will, through a specific and prescribed network upon which their OT rides. There are certain organizations who have specifically identified what key controls need to be implemented and have a phased approach. All of these different tier 2 instructions, guidance, oversight does and can reduce costs. In other organizations where that doesn't exist and the language from DoD 8510 is transcribed pretty much seamlessly all the way down to the level 3, there can be a great deal of cost, because as your system owner starts churning out the documentation that we spoke about earlier, the interpretation of it being accurate or needs to be modified or whatever goes through a lot of different iterations, right? And in doing so, each iteration is going to increase costs. So not only the personnel you have supporting the system owner is important, that influences costs, but also the maturity level and the guidance provided by your command, your tier 2 or your AO shop.
Thanks. Thanks for the feedback on that one. Like I said, that's a tricky one to nail down, because the systems vary very greatly, and requirements can differ, like you said, depending on your leadership. So that's a hard one to really once again, it's not the one size fits all. So appreciate the feedback on that. There was a question. An individual wanted to clarify something back on the step 2 in the process. They were asking if it was mentioned during the control selection process. Does it, if the AO needs to approve any tailoring before the controls are implemented? Can you clarify that for us?
Yes, the AO, as part of your security plan, you're going to tailor whatever control that you have in there, and you're going to explain why a control is not applicable, there has to be some operational impact or feasibility of that control on your environment. So as part of that development of the system security plan, where you begin to tailor out certain controls, and again, it's not based on specifically applying the overlay. You have to look at all of your components, and if it's applicable, then it's applied to that portion of your environment. And then the AO does approve your control selection and any tailoring that's done.
If those who are familiar with the system of record, the EMAS, that particular module that you probably spent a lot of time in importing and exporting is your implementation plans. And specific to the approval, you'll see DoD warning banner needs to be displayed. Those types of controls being implemented are called out in your plan, but you're not going to do that on a PLC. You're not going to do that where it's flash memory. So those types of things need to be identified. And lastly, I'm sorry to kind of harp on this. Kind of goes back again to if your AO is going to approve a plan and you haven't identified what inventory you have, you don't really know what controls can be applied, what is technically feasible. You really don't know. But it is key to note that whatever you do right and your AO does and will approve, you will have to answer for it. And the amount of security mechanisms that you can't apply to your environment that you realize way too late in the game will impact that AO's decision to accept that risk and for how long.
Okay, great. Appreciate you, clarifying that, situation on that step. Appreciate that. So I think we've got maybe time for just one more question. And once again, this is kind of a training and education question. Individual is curious as to, is there a specific skill set that an individual would require to do the work for the risk management framework type of process? Is there, a particular set of skills that's needed for that?
That would depend on what your role is within cybersecurity. RMF is just a framework, and there are a number of different roles within cybersecurity and within risk management framework. So to identify a specific skill that you would need, it's kind of difficult. Where are you working at? What is your role? Are you working at tier 3, 2, or 1? Because there's a different set of skills and experience that's required. So it would vary.
Yeah.
See?
Yeah, are you on the network defense team? Are you an assessor? Are you an engineer? If you're an engineer, are you engineering towards an IT solution? Are you supporting the OT environment and engineering various security requirements? Are you in procurement? Are you the system owner? Have to understand system lifecycle and understand those types of aspects. It's depending on your role will dictate what you need. Now, there are opportunities to identify based off of your role what what knowledge, skills, and abilities you need. 8410, I think, or 8410, 8140. 8410 workforce improvement. I think it was on one of the previous slides. Specifically talks to that. It's still in work to identify 8140.01 cyber workforce management. What knowledge, skills, and abilities are specific for an OT cyber professional, but the other roles are pretty well defined. So that would be a good starting place. Also, look at 8570, which will not only tell you what industry certifications are looked at fondly by DoD, but also it'll tell you some experience background based off of those roles. So there's some information out there, whoever did ask, where you can find that information out. There is no one-size-fits-all, and as my mentor used to always say, cybersecurity is an umbrella. And thus it covers many different aspects of operation. And typically, whatever you're interested in when it comes to system development or system lifecycle, there's a cybersecurity role for you. So don't think you have to be pigeonholed.
Okay, that's great. You've provided some documents that folks can go and run down and take a look at to try and get some more information on the kind of skill sets that are needed. So that's a good direction. Appreciate that. So so we've had a lot of comments in our chat session, and so one thing that we'll definitely try to do, we'll try to gather up those comments and post them onto our website, and we also have our tech forum on our website where folks can continue the discussions. If there are more questions, you think of more questions after the fact, send them in, info@csiac.org, and we can see if Ram, Paul, and Stephen, may be able to spare some time to answer those questions for us. Once again, I'd like to note in particular that Mr. Darrell Hagley has posted a number of references and comments as to changes that will be coming down the road, different changes in this area. So there'll definitely be some useful information that you'll find on the website after today's webinar. So I encourage you to go and check out the additional information and resources that you'll find there. And finally, once again, I do want to thank Dr. Hollington and Mr. Brewster for taking the time, sharing their experience, expertise with us. These are folks that have been working in the trenches. They're where the rubber hits the road, and they've got the real world experience. And want to thank you, gentlemen, for taking your time and sharing your expertise with us today. We appreciate it very greatly.
Well, we thank you for the opportunity, and we greatly appreciate it. Anything we can do to help, we're available.
Okay. Well, thank you for that offer, and we'll probably take you up on that. So I just want to wish everyone, have a good day, and we'll hope to see you next month's webinar. I think we're going to be we're shooting for the 14th of November, and we're going to be having our folks from the Defense Modeling and Simulation Coordination Office. They're going to be talking about their catalog, different simulation tools that are available for folks to take advantage of. And so that'll be the topic for next month, and we'll hope to see you down the road. Thanks. Have a good one. Bye-bye now.